What was pure science fiction for decades could finally become reality. Researchers have discovered that the famous warp drive from Star Trek does not necessarily violate the laws of physics, and have developed a concept for generating a warp bubble that does not require exotic negative energy. If we succeed in making faster-than-light travel a reality, the vast expanses of space would no longer be an insurmountable obstacle. But how realistic is this? How does this crazy propulsion technology work? And what does it take to build a real warp drive? Be sure to stay tuned until the end and find out with us. More than 7,500 exoplanets in nearly 5,100 systems. Experts have now succeeded in detecting countless alien worlds orbiting a host star other than the Sun. In fact, the closest known exoplanet to Earth, Proxima Centauri b, is only 4.2 light-years away. And since it orbits in the habitable zone of its system, which allows for the existence of liquid water, it is even excitingly suspected of being habitable. In astronomical terms, 4.2 light-years is no more than a stone's throw. But unfortunately, even such stone's throws are simply not feasible for our current probes and spacecraft. The bottom line is that the distance of the Proxima Centauri system is over 40 trillion kilometers. And while Voyager 1 flies through space at a speed of about 61,000 km/h, the old probe would take around 75,000 years to reach our exoplanetary neighbor. But even the fastest man-made object to date, the Parker Solar Probe, would still take around 6,600 years to reach Proxima Centauri b. As we can see, even a record speed of 692,000 km/h is not enough to make us forget the vast distances of space. But that could soon change. For decades, one idea has captured the imagination of science fiction fans and scientists alike. The dream of warp drive, a technology that allows spaceships to travel faster than light without violating the laws of nature. This concept first appeared in the 1960s in the Star Trek series. But how? And this is the crucial question. Is it even possible to fly faster than light? According to the theory of relativity, we're dealing here with a universal speed limit that simply cannot be exceeded. Or can it? Well, in fact, the crew of the Enterprise already showed back then how it could be done. In the show, Captain Kirk and his crew overcame unimaginable distances by bending and compressing space itself instead of simply flying through it. The problem with Alcubierre drive. In the years that followed, scientists explored the question of how this miraculous propulsion technology could be turned into reality. And so it came to pass that in 1994, Mexican physicist Miguel Alcubierre turned the Star Trek concept into a subject of real research, describing in his work how space-time could contract in front of a spaceship and expand behind it. The ship itself rests within a space-time bubble while space-time is distorted in front of and behind it as if space-time itself were carrying the spaceship. The so-called Alcubierre bubble could, at least in theory, move faster than light without the ship itself exceeding this limit. The physicist thus elegantly circumvented the natural speed limit of relativity theory. But the price was enormous. To create the corresponding local distortion of space-time, one would have to expend as much energy as is stored in the entire mass of the planet Jupiter. And then, of course, there's the question of how to stretch and compress space-time in the desired manner. Alcubierre suggested surrounding the spacecraft with a ring of exotic matter with negative mass. The idea was that this ring would then act as an antagonist of gravity and deform space-time through its influence. The small but crucial catch, however, is that such a form of negative energy has never been observed in nature. According to current knowledge, this exotic matter simply does not exist in the required quantities, which is why the dream of real warp drive was initially dismissed as a purely mathematical thought experiment, a concept without negative energy. A few years ago, however, a new study made the rounds that brought the concept of warp drive back into the spotlight. Published by Alexei Bobry and Gianni Martia from NASA's Advanced Propulsion Laboratory at Applied Physics. The approach is based on the basic principle of the Alcubierre bubble, without relying on exotic negative energy instead of a ring of matter with a negative mass that distorts space-time. The two physicists work with positive and thus physically feasible energy whereby the central idea remains the same. The spacecraft rests in a bubble while space-time is contracted in front of it and stretched behind it. The crucial difference, however, is that the negative energy is replaced by extremely strong gravitational fields. In general relativity, gravity is caused by energy and mass, and the researchers show that based on this principle, space-time can be curved in such a way that a bubble is created that transports the ship without accelerating it itself. But does this really give us a solid concept that will enable us to jump to foreign star systems within a realistic time frame? Well, unfortunately not quite yet. While it's possible on paper to reach 10 times the speed of light with the help of the Alcubierre bubble, Bobbick and Martia's model remains below the speed of light. And here too, the faster you want to move the bubble, the greater the energy requirement to achieve significant speeds. You would therefore need energy on the scale of entire planets, still much more than we could generate or control with today's means. But despite all the practical hurdles, the study's authors do not want to dismiss their work as pure mathematical speculation. According to them, their model would at least represent a starting point for placing the concept of warp drive on a theoretically feasible footing. And the experts are confident that engineers will eventually find a way to turn it into reality. How scientists created a warp bubble. We will need to be patient before we can travel from one planetary system to the next at a touch of a button. However, in retrospect, every partial success could turn out to be an important piece of the puzzle that paved the way for real warp drive. This also applies, of course, to the first real warp bubble, which U.S. physicists created in 2022. Yeah, you heard right. Experts have actually succeeded in bringing a little piece of Star Trek into reality. The team led by Harold White from the Limitless Space Institute had this to say: "To avoid any misunderstanding, I want to make it very clear that our discovery is not an analog model of a warp bubble. It is a real, albeit extremely tiny and very weak warp bubble." But what had happened? Well, in fact, the scientists had not initially set out to create such an exotic structure. Instead, White and his colleagues have been conducting experiments with so-called Casemay effect between metal plates when an astonishing phenomenon caught their eye. Briefly, the Casemay effect is a physical phenomenon from quantum field theory that shows that even the supposed nothingness of a vacuum is not completely empty, but is permeated by quantum mechanical fluctuations. According to their own statements, the researchers ultimately discovered a structure at the micro or nano level that resembles the distribution of negative energy density just as the Alcubierre principle requires. Against this background, the researchers described their finding as a real, albeit small and weak, warp bubble that not only confirmed the predicted ring-shaped structure and negative energy properties, but could also show how a warp bubble could be created on a much larger scale in the future. Before that happens, however, the idea must first be tested on a small scale. To this end, White's team has developed a concept for a very small warp spacecraft that could travel from A to B by generating its own warp bubble. The mini-ship in question is to consist of a sphere with a diameter of 1 micrometer located inside a cylinder with a diameter of 4 micron. In initial experiments, this principle showed a, quote, three-dimensional Casemay energy density that matches the requirements of the Alcubierre model. Searching in space. Are there already warp signatures out there? But what if there really is an enterprise traveling through space? If an alien species has already managed to build a starship with warp drive, would it be possible for us to detect it? Well, that's exactly what a team led by Katie Claw from Queen Mary University of London wanted to find out when they investigated how potential warp signatures could be detected. The premise is that no warp bubble can be permanently stable. At the latest, when accelerating or decelerating more strongly, the deformation of space-time would have to collapse. And the scientists examined how much a collapse of the warp drive would manifest itself and whether it would be detectable. To do this, they simulated a collapse of a warp bubble about 1 kilometer in size in which a spaceship is flying at about 10% of the speed of light. The bottom line was that the collapse of the warp bubble generates short but distinct disturbances in space-time in the form of gravitational waves. To quote, "This signal comes as a pulse that initially does not contain any gravitational waves but is followed by a period of oscillations with a characteristic frequency. More precisely, this frequency would be around 300 kHz and thus in a range that our current gravitational wave detectors cannot measure. Fortunately, however, the technology for detectors in this higher frequency range already exists and the intensity of the signal would even be detectable now. This would differ significantly in form from the signal of merging black holes and would be more similar to the collapse of an unstable neutron star or a head-on collision. However, there would be a longer tail in the lower frequency range, especially at higher warp speeds. In plain language, this means that it may be possible in the future to detect the signatures of a warp drive, provided that the spacecraft in question is moving close enough to us. And although scientists consider the probability of this to be rather low, they find the possibility exciting enough to keep an eye out for it. And if you look for the subscribe button now, you'll never miss a new video from us again. Feel free to click the thumbs up and subscribe to stay up to date from now on. See you soon.